Hello student, I am Neyaz Ahmad of DAB Public School CCL Grade. I come with this new video because I found most of you are facing problem understanding household circuit. What is a household circuit? Here we will discuss. So in your house you may have seen two wires comes from the supply line, and one is called live and other is called neutral wire. And this live wire has red color cover and neutral wire has a black color. You can easily identify these wires in your house. If it is red color, it must be live wire, and if it is black color, it must be neutral wire. You may have seen what third color wire, that is green wire. Generally in Indian houses you cannot find this easily, but it is for safety purpose and we need this. The first question arises how we connect our appliances to the line. Only two wires are needed to connect our appliances, and they will run on that two wires only. The third wire we will connect to its body, and we will discuss it later what is an earthing wire. So you can see I have connected the bulb and the fan parallel to each other. That is, one end of the bulb has been connected to the live wire and other is connected to the neutral wire. Here once again the fan has been connected, one end to the live wire and other to the neutral wire. The first question arises where to put the switches. Switches must be connected between the appliances and the live wire. So the switches must be connected here. So what is the significance of connecting the switch here? It breaks the circuit, number one, and number two, if it switched off, if you touch the appliances or this side, you will get no shock. But if you connect these switches to the between the appliances and the neutral wire, what will happen? See, it remains connected with the live wire, and if you touch the appliances, if it is appliances, you will get shock. So the switches must be connected between the live wire and the appliances. Here you can see. We will discuss what is the significance of connecting this in parallels. So you see what happens. Suppose that this has a potential of 0 and 220 volt, the live wire. So net potential difference between these two wires is 220 volt, and all appliances we design to work on this potential difference. If suppose that the bulb has been connected to this two, the potential difference across these appliances is 220 volt, and it will work properly, it will draw current of its own need. That much it needed to run properly. Similarly, the fan will is also working under the potential difference of 220 volt, and it will draw current as much it required. But connect this, suppose that this wire I have increased to a length, and one appliance is heater and bulb, geyser, etc. I have connected in series. What will happen? All this will get as we have discussed in series connection. These appliances has some resistance. So these appliances have been connected in series. The net resistance across the two wire increases. So they will get different potential, I into I1, I into R1, I into R2, I into R3. R1 is the potential resistance of heater, R2 resistance of bulb, and R3 resistance of geyser. So they they get potential less than they require. One thing. Number two, if they are connected in series, the net resistance across these two terminals increases and the current in this section decreases. So they do not get the enough current to work properly. They will get less current. Therefore, we cannot connect this in series. We must connect. Another thing you must remember, if suppose that bulb get fused, one get fused. So sir, there will be a break of circuit and other will not work properly. So two main thing, that's why we connect appliances in household in parallel. Number one, when we connect in parallel, they get proper potential difference to 20 volt, and they will draw current as per their need. Number three, if one get fused or one get damaged, other will keep working with the line. But in series connection, the potential difference says the appliances will be different and less than 220 volt. Number one. Number two, because of the increase in resistance, the current in the section will decrease. All will get same amount of current, and as we know that they require different amount of current, so they will not work properly. Number three, if one of them get damaged, then other will not work. Now we will discuss importance of earthing, why we need earthing. To understand this, let us see this arrangement I have done in our house. This is the live wire, and this one is the neutral wire. It comes from the supply line directly into your home. Now I have connected these two appliances in parallel with these two wires, that is live wire and neutral wire. Now you can see there is a third wire I have connected to the body of the appliances, such as this is the computer, and I have connected this wire to the body of the CPU, central processing unit. And here this is the refrigerator, and I have connected the earthing wire to the body of the refrigerator. How it saves? Suppose that somehow this live wire get connected with this body of the refrigerator or body of the CPU, it will store charge. If we touch this at that moment, we will get shock, and sometimes it may be very dangerous to the life, to our life. So the green wire what I have connected to the body of these appliances. What happens if it can get touched with the body of the refrigerator? Some charge will accumulate on its body, and since it is connected to the earth, these charges will flow into the earth, and there will be no accumulation of such charges. Similarly, live wire comes in touch with the body of this one, again it acquires charges on its body, and because this is connected to the earthing, so these charges again will flow into the earth, and there will be no charge in that case. And if I touch this body, then we will not get shock. Why we get shock? Because suppose that it is not connected, charge is present on its body, accumulated on its body, and when I touch this, these charges flow through us, and that is the reason of getting shock. So live earthing help us to save our life from electrical shocks. We will discuss short circuiting, overloading, and fuse. Advantage of adding fuse to the electrical circuit, and what is short circuiting. First of all, we will discuss it. So what is short circuiting? This is the live wire and neutral wire. Somehow the insulation of these two wires melt down. What will happen? They will come in touch. Suppose that these two wires come in touch, they get collapsed. So in that case, the resistance of the circuit becomes very minimum, and there will be a tremendous amount of current flowing through this, and that much amount of current can melt down or burn out the whole circuit. Not only the circuit, but it can damage the other appliances connected to the circuit. So short circuiting, it is when live wire and neutral wire comes in contact, there is a large amount of current flow through the circuit, and such a situation is called short circuiting. Short circuiting may be very dangerous. It can lead to the fire in your house. So to avoid this short circuiting, we need to use fuse. What is fuse? A fuse is a thin wire connected to the in series with the live wire. This is the live wire, and I have connected this fuse in your live wire in series. How it works, somehow if these live and neutral wires comes in contact, it will be a short circuiting case. There will be large amount of current, and in such cases this thin wire that has high resistance and low melting point, high resistance and low melting point, so it produces tremendous amount of heat at instantly. I square RT. R is very high, current is high, and time, in a less time there will be a large amount of heat that will melt down this wire. So a fuse wire, the characteristics of a fuse wire, it should have a large resistance or large resistivity, and low melting point. It should melt down in a very small amount of heat. So when it is connected with a live wire and there is a short circuiting somewhere in the circuit, there is a large amount of heat, so there is large amount of current, amount of resistance, and in a small time there will be large amount of heat that will help to melt down this fuse wire. So a fuse wire is very useful in your circuit. Next one is overloading. Therefore, a student, a fuse wire should have a large resistance and low melting point, so that when there is a short circuiting, there is a large current, there will be large amount of heat producing at the moment, and that will lead to melt down it, and that when it melt down, the circuit breaks, and it save our house as well as other appliances connected to the circuit. Now the next point is overloading. So what is overloading? Here you can see I have drawn a circuit. This is the live wire and this is the neutral wire. Fuse is connected to the live wire. The switch is also connected to the live wire, and this fuse can pass 5 ampere of current in the circuit. This is designed such that it can pass the current of 5 ampere only. Suppose that this is a appliances I have connected that require only 5 ampere of current, then this circuit will work properly. But if I connect here a heater that needed 5 ampere, more than 5 ampere of current, then this will draw more than 5 ampere current, and in such cases it is called overloading, and the circuit will break easily, because this fuse has been designed for 5 ampere but it is drawing 7 ampere, so there will be a large amount of current, and as per this formula there will be a large amount of heat that will melt down the fuse. So there are such cases when something or some appliances draw current more than it needed, that case is called overloading.